Hi, I'm Matt with Schematical, and today we're talking about how to use Kinesis to push information into S3 in Parquet files, and then query that using AWS Glue and possibly Athena. So I've got a fun little graphic for you that we'll kick this thing off with. By the way, if you like this stuff, like, share, subscribe, etc. But let's just jump right in. All right, so the pipe symbolizes the internet because it's funny and it's like Mario Brothers. Then you can see information heading into the system, hitting the load balancer, and then being distributed to the two application servers there. Little smiley faces and all that. From there, one of the application servers sends the record you're creating there, so we'll just assume this is a create or an update here, to the database. It updates the database. Now, it's a little unclear here because I wanted to show multiple servers, but technically the first server would be sending the event to Kinesis from there. So Kinesis is the big orange bucket there. Kinesis is an amazing tool that lets you take in one record and have multiple consumers consume it. So like different workers versus like SQS where you can only have one consumer consume it. This one in this diagram, a Lambda is consuming it, and we're using AWS Firehose, which I really didn't know how to draw a different diagram for, but basically to pump that information in Parquet file to the S3 bucket. So all that information lives in cold storage, is stored very cheaply by comparison, and you can pick which S3 method you want to store it with, all the way up to Glacier or Ice, whatever they're calling it now. And then you can use AWS Glue to crawl that information. AWS Glue allows you to query the files stored in S3 and crawl them and get table structures and then run, different big data sets against it. So the use case for this, which maybe I should have led with, but the use case for this is if you have big data clients, people that are running, long historical data records that query, tons of different tables or just really big queries that you don't want slowing down your day-to-day stuff. You use something like Glue. And the reason I picked Glue over, say, like an always-on Redshift is that Glue by default is serverless and you only pay for what you use, not including storage. But again, you got some options there. Redshift does have a serverless, by the way. I just haven't gotten around to playing with that yet. Look at that magic. Now I've got a little magnifying glass there symbolizing AWS Athena. And that is what the two-dimensional icon looks like, is kind of like that magnifying glass there. But if you wanted to query using MySQL, you should check out Athena. So yeah, that's roughly our network map. Let's move on to the actual Terraform code. Now, as per usual, I'm moving way faster than I probably ought to be because I'm juggling a million things at once, and this isn't even made into a module yet. So I'm just going to walk you through the Terraform script. If you'd like to see it as a standalone module you can use, feel free to ping me, leave a comment, start this repo, jump on the Discord, etc., etc. Moving on. All right. AWS IAM policy document. Of course, we need a million policies. This allows Firehose to assume the policy so it can behave according to this rule here. We've got some usual stuff. Create logs. You're going to want that. If for some reason it can't reach the S3 bucket, that's going to be a problem. Firehose will need to be able to describe the streams as well as do a lot of other things for your Kinesis stream you want to pipe events in from. By the way, I hooked this up to Drawn by AI. If you're not familiar with that, that's my fine-tuning of Stable Diffusion product that I've got out there, otherwise known as Chaos Pixel. Drawn by is just the part where you've got animals in there. Check out my other videos for details. You'll need to be able to do S3 put objects and get objects and describe into the S3 bucket you're storing in, as well as pretty much all things Glue as it pertains to your other stuff. And I need to clean up this security stuff. Obviously, that's something's a little bit open for me, but we're moving fast here. And then here we'll need to be able to write to CloudWatch logs. So I gave it a log group, definitively declared that myself. And then AWS CloudWatch log stream, same thing. It's just a sub part of the log group. And then here's the Glue storage bucket. So this is where Kinesis is going to pump that information into. So this is where Kinesis is going to be pushing into that S3 bucket. That's the S3 bucket we're talking about right there. And then here's the AWS Kinesis Firehome delivery stream. And this one doesn't really exist in my diagram. It's just part of Kinesis. If I could figure out a good icon for it, maybe I'll add it later. So you can see here I defined where the source is, and that's the Kinesis stream that's going to be defined below. And you can see, well, actually, technically, sorry, I apologize. The Kinesis streams were already defined in the main Chaos Pixel environment stuff. So you'll have to pass that in, actually. And then here you can see that this is the bucket I'm sending it to. There's the role I defined. Because we're using Parquet, you're kind of limited. For testing, you can shrink down the interval and the size. The interval is roughly how many seconds before it writes a Parquet file or whatever format you're using. And the buffer is, I believe, in megabytes, how many megabytes it'll buffer before writing, so it's not constantly writing to S3, which is good, saves you money. Wonderful. You want to make sure you output your errors there. You can do fancy prefixing with partitioning. I have not had a chance to implement that in this implementation. I'm moving pretty fast, like I said. So either way, data format, conversion, configuration, we're just parsing JSON and we're saving it as Parquet. There's nothing really too fancy about it. So here is your Glue catalog database. So you're defining this Glue catalog database because this will start to exist in AWS Glue first, but you also can reference it with Athena. So that's cool. You're going to want to, for your default IAM principle, you probably want to give it, a bit more than just select. As you become more complex and you bring on more users, you're going to want to be more granular with this. But this I needed so you could drop stuff. It was really a pain to drop this stuff without that permission, despite this permission. Either way, so here you can see we're defining an Athena data catalog. And again, you guys can completely omit this if you'd like to. If you've got other interfaces, I should probably mention Pandas in there. Pandas is a tool you can actually query directly from Glue, especially if you're really versed in Python. Here's an AWS Glue registry. You don't need to define this per environment. So like I said, I need to move that out. But basically, it allows you to have a registry of certain Glue-related data that you can then pull up and, it can be stored and referenced in other places. And here's your Glue catalog table. So we created a table here. Now, here's something I'm still playing with. I was unable to get it to actually pull from this one as of the moment. I've done this manually without Terraform using the crawl, and we were able to get that to work using this crawler down here. This one, a little more sticky, so I'll have to get back to you on that one there. The AWS Glue crawler right there. It's attached to the database. It knows where it's piping it into, and it knows the bucket that it's going to crawl right there. And of course, we need some policies so it can access the bucket, all the usual stuff. And here is the Glue output bucket. So when you do a report in Glue, it anticipates it's going to take so long, it's going to have to push it out and save your output so you can pull it up and retrieve it asynchronously, because you're not going to sit there and wait for that call to be done. Usually these things are pretty massive. And if you're only querying small data, chances are Glue and this whole setup is not for you. I should also warn you that Glue is billed in 30-minute units and 10-minute minimum duration for each crawl, so don't use it for small queries, all right? It's like, it would be way overkill. I did 2 queries, and I think it was billed 9 cents, so it adds up very fast. They were very small queries too, small data set. All right, so we're back in here. There's the bucket we were just talking about. Here's the IAM role. We don't really need to discuss this. All the stuff you need, the permissions are in here. You might need some touching up here. I'm a bit generous right now. But before I go to a module and publish it that way, I will go ahead and fix this. Let's go ahead and take a look here. We can start with Kinesis over here. And I only spun this up for Chaos Pixel Dev right there, but this is our basic stream. It gets records that get passed into it. Not a lot of traffic on Chaos Pixel right now. And the fire hose that's attached to it, because I only spun up one for Dev so far, is right here. And this actually will take records that are pumped into that Kinesis stream that we mentioned right there, and it will pump it into the S3 bucket we created at the specified intervals. And then errors get stored there, so check that every once in a while. So you can see our data catalog tables right here. So this is the Parquet one I created here, and this actually went ahead and crawled it. I ran a crawler, and it was able to finish crawling in about 56 seconds, but all I had in there right now is demo stuff. There is some data from Chaos Pixel / drawn by getting piped in there, but it's really, I'd love for it to be enough traffic that it's worth querying, but it's not. I just wanted to get the demo set up for this video for now. And then the final part, if you're inclined to use Athena, is, oh yeah, don't drop that, is here, where you can manually run these, but obviously you'll use an API or something like that to go ahead and pull your information there. So you see it's got my fields here. And we could see the last time I ran it, this is what it looked like here. I'm not going to rerun it right now because it's just going to charge me. I guess I could rerun it. Screw it. We're rerunning it. It'll charge me another 9 cents, which is worth it to my viewers. All right. So there it selected the prices from the Parquet files in there. Exciting, huh? So that's how you build a serverless, on-demand data warehouse, data lake, whatever buzzword you're feeling like. This one, I guess, would be more of a data lake. Maybe I didn't mention, but you will have to program your code base to publish to Kinesis, so make sure you do that. But yeah, that's roughly what it looks like. That is a really, really bare bones Kinesis to Firehose to Glue to Athena setup that you can use to save money, get load off your primary database, while allowing your big data customers to query your system. Just a pointer. If you have big data customers that like to spam you, I would be quick to pass along the cost of the glue crawler with a markup to them if I was you. Just something to consider there. Data might be free, it might not. I'll tell you what's not free: CPUs, compute resources on AWS. That stuff costs money. If you need help implementing this stuff, feel free to hit me up, schematical.com. I consult on this stuff. I run group coaching on this stuff. Hop on the Discord. Feel free to chat me. Leave a question. Leave a comment on YouTube. I'm here to help. And if you're interested in my book, 20 Ways to Save Money on Your AWS Bill Today, go ahead to schematical.com/book. Check that out. That is where I do a less deep dive of this. This will be a slightly deeper dive of that. We'll do more videos on it as I go. All right. Thank you guys for watching. Have a great day.